In this paper, we present a robust vision system for 60 object pose estimation. Our framework proved its capabilities as part of our third and fourth place winning entry for the Amazon Picking Challenge 2016. The goal of warehouse automation is to achieve a fully autonomous system for picking and placing objects. A critical component of this task, as with many other robotics applications, is a robust vision system that can reliably recognize and localize objects in the environment. However, this can be a very challenging task, especially in the warehouse setting, due to cluttered environments, a large variety of different objects that need to be recognized, object occlusion, and sensor limitations. To overcome these challenges, we present a robust vision system for object pose estimation that leverages multi-view RGBD data and big data with self-supervised learning. Our approach follows a two-stage pipeline. First, given an RGBD image, we feed it through a trained, fully convolutional network to perform object segmentation and label each pixel by its corresponding object. We do this for multiple different camera viewing angles in order to maximize the information gain about the objects in the scene. As an example, here we show a video of our robot looking at the shelf bin from multiple view angles. The RGBD camera is located on the gripper. And here the robot looks at the tote. After collecting all of the RGBD data from multiple views and passing each image to the fully convolutional network, we use a forward kinematics of the robot to fuse all segmentation results together to create a segmented point cloud. Next, we take our segmented point cloud, and then for each object, we align a pre-scanned 3D model to the segmentation in order to estimate its 6D pose. This is done for all objects in the scene to get our pose predictions. Training a fully convolutional network to perform object segmentation typically requires large amounts of training data with manual labels. However, gathering and labeling such a large amount of training data manually for the warehouse setting can be very expensive. Therefore, to train our deep models, we propose a self-supervised framework to generate a large labeled dataset without tedious manual annotations. To gather training data, we collect RGBD images of single objects in scenes from different viewpoints. Since we can move the robot in accurate and repeatable ways, we can capture the empty background of the scenes from those same viewpoints. We use the information that we have collected in order to isolate the foreground from the background. The foreground becomes a pixel-wise object mask, which is then used as the segmentation labels to supervise the fully convolutional network. This process of labeling is entirely automatic and can be scaled up to more object categories easily, which is an important property for warehouse automation and other constrained robotics applications. Ultimately, our object segmentation training dataset for the Amazon Picking Challenge contains over 130,000 high-quality labeled RGBD images for 39 objects. As far as we know, this is more than 100 times the training data collected by any other team using data-driven methods. Here is an example of our full vision system in action with the robot during our STO task finals at the Amazon Picking Challenge. At test time, our vision system was able to correctly estimate the 60 poses of the objects in this challenging scenario. Here, as a result, the robot successfully picks a target object from the tote. As part of our contributions, we provide the code for all components of our vision system as reusable ROS packages, with CUDA support for GPU acceleration. We also provide all of our trained models and datasets online.